Hello friends, today I am going to discuss calculus. Calculus, it is a part uh, of Python's. Just how mostly I have to learn here. We have to learn here how to write some calculus formulas in a Python's. So first, how to represent a mathematical expressions in a SciPy and how to perform basic simplifications and transformations of such expressions. So first we are going to ready to explore the symbolic calculus and analysis, and then we can apply some applied mathematics and also the great number of the applications throughout the science and engineering. So the center now the concept in the calculus to the change functions as a input variables are varied as a quantified with the derivatives and differential accumulations of functions over the range of input, and otherwise the quantified by the integrations also. So let's see derivative, and first I try to learn some derivative functions how to use. So derivatives of the functions just describe like a rate of change at a given point. Suppose you are putting at the 2 centimeter, and now so at the 2 points how to change with the respect of this value. So similarly we can take a x, so x points we can change with the respect to the so rate of change only we can say understand here. So simply we can calculate the derivative of a functions using a simpy.diff. Now the alternative use also the diff methods of a simpy expressions. So now I try to write something of functions f will equal to simpy, because I have already downloaded the simpy. So let's see, I think import. Previous class I have already discussed number of things, so don't worry. Simply I have already downloaded these things, but let's try again. So it is possible to work here. So sometime if your internet connectivity is not a good, so it is running as a very slow way. So here is also, and because we are also using the advanced level of some functions, so this will be the very, it may be possible to slow, but let's see. My motive is the how to get the complex functions to the very within a seconds output right here. So let's see, just functions will equal to simpy dot functions. I think we have already discussed previous class. So if you don't have the idea, just you can go function mction and parenthesis right here f, and with respect to the x, so you need to write the another parenthesis and x value. If you want to write with respect to the y, so you write there t, to t you can write there. And now I am going to write here simply function, where did I get something wrong, sympy. Okay, so I think it is not working. So x, So I am going to write with respect to the x. So this is not a way to here, x is not a defined, because I am going to write here the abstract functions fx with respect to the x we can. And now another way I try to f also, u n c t I o n, I think s y m p y. So let's see the alternative one more, don't worry, just I am going to write here simply s y m p y and diff functions diff differentiations, and I can also write yesterday just to discuss here f and x. So this functions has been written, this is also v, f is not a defined. I think something has gotten some mistakes like a simpy here, so it is running and not running. Simpy is as this word, another is also. So I think let's see the more functions, don't worry, just I try here, is it working or not working. Other functions, if other functions is it working and not working. So let's try here simpy and x. Yeah, it is working. So I hope it is possible to work. I think now, yeah, it is working. So I don't think so. If like here, either functions as it is there. Let's try again. So now it is working. Okay. So sometimes I told you just connectivity problem. Yeah, it has been written as this. So this is the differentiate with the this functions. You can write also the x plus 1, which it is possible to you can write here. So and it represents the higher order derivatives. So we need to do is to the repeat the symbols of x. Okay, the argument list in the call to simpy dot difference diff differentiation, right? But let's see, just I want to write here double differentiation, so we need to write here simply simpy dot diff and need to write here the functions again x right here. So let's try here. So it will be look like a double differentiation twice, right? So this means similarly we can write here if 3, 4, 5 times. So you can say what happens just if you write the nth derivatives. Most of the time we did as a Taylor's and some this type of the differentiation put there. So let's see, just if simpy dot diff, right, bracket start, and I need to write the 3, so you write here the f dot x dot 3. So let's see what happens. Simpy can easily represent as a 3 times. Yeah, so yeah, it is possible to, it has been. Similarly if you write the n here, look here, is it possible to write here? I think it is. So you try n as a, because n times n minus 1 times, so no, it is not a working right here. So need to write here any 100. So is it possible to write? So keep in your mind, just you must write here, yeah, integer. So it is equivalent to this one. So let's see. Now next I am going to write here the another function. Look like the method. I'm using as a variable. So g as a variable, g will equal to, and simply dot function simply dot function and bracket start g, okay, and with the x and y, x comma y. So now another variable g dot diff x comma y. So this method is just expanded of the multivariate functions. Look here. So like here, another, just we can also write with respect to like this another function. Next the g dot, because this g functions has been look like this, so g dot diff, and I am going to write here x comma 3 and y comma 2. So x comma 3 and y comma 2. This means derive these functions here 5, and with respect to the y as a square and with respect to the x as a cube. This is a v. So it is equivalent to the g x x x, g x x x thrice, and y as a twice. So we can easily understand these are the formal derivatives to undefined functions, but we can also express, evaluate the derivatives of the defined functions as an expression which result in a new expressions that is equivalent to the derivatives. So let's see, I try here, I am getting the one another just expressions like a expr, because we have already taken the previous class, and x to the power, right here the 4 plus x to the power 3 and plus x to the power 2 plus x plus 1. Okay, so exp, now expr dot diff with respect to the x. So now I am going to the whole expression, any whole functions can diff x. So differentiate with the respect to the x, so you can easily get output. So first diff, and this one x to the power 4, so it has been differentiated as a 4x cube, and now the x square, x to the power cube means 3x square, so we can easily get a output expressions. Now if you need to the double differentiate, so we can write here expr, so expr dot diff, and you write here the xx, and then we see here the output will equal to this one. Similarly, sometimes you can write here the trigonometric functions, just I have already discussed in previous class. Now other expression, just I am taking the three variable. I try here. So x, y and z. So let's see, expr will equal to, now bracket start, because by x plus 1 and whole to the power something like a, you can take a power 3, and then I am going to write here something x to the power 3, and it will multiplied with a, now it is a multiplied with y to the power 2, again will multiply z minus 1. Okay, close this bracket. Now let's see, just I am going to expr dot def x comma y comma z. Okay, so let's try here. Yeah, this is not working, so I think expression x plus 1 to the power 3. Now it is a, again the y. Okay, this one again double, this one has been taken look like this. Okay, and y to the power 2 need to go here to the power x, and I am going to expr dot df x comma y comma z. Now it is not okay, now I think it is working, because we need to, okay, no, just I am getting some mistakes. Z, so z is not defined. I think I have written here the z as a variable, so x, y and z. So z has been defined. This means you cannot get here the output. Okay, so x, y to the power something, but we don't have the z, so z is not defined. So I think this type of the code is not working, don't worry. So let's see, just if I write here, but I try to solve this problem also, don't worry. Let's see, I think it will work, because x and y have been defined, but yz is not working, so we have to work. So I think this type of the expressions can get something like a output. Otherwise I think internet is not working, something is, got it. So this has been look like this. So now let's see the how to write the complex differentials and how can solve these complex differential equations. So now similarly need to create a like a trigonometric. So expr dot will equal to simpy dot sine, and now bracket start, x will multiplied with a y, and this has been another is a will multiplied simpy dot cos, and if I write x by 2, x by 2, let's see, it will make some complex value. Let's see. So I think is it working or not here. I think it is. How to appeal? So right here ex pr dot differential with respect to the x. So okay, sorry, just I have gotten something problem here. So x with respect to the x, yeah, and y it coming from somewhere, don't need here. I think now good. Let's see. So yeah, it has been look like this way. So you can easily differentiate some complex value. And another is that, so derivatives are usually the relative easy to compute, and the simply dot differentiate diff should be able to evaluate the derivatives of the most standard mathematical functions defined in a simply. So simply dot def on an expression is the directly result of new expressions of the most of the time we are using as a latex. But if we rather want of the symbolic, don't need to learn the other language, so you can easily represent to the derivatives, and very easy way simply dot derivatives passing. So let's try here. Just I am going to write here as a variable d will equal to simply dot derivatives d e r i v a t i v e derivatives bracket start y m p y simply dot ex pr ext exponential form right here. So simply s y m p y dot cos bracket start parenthesis x, and this has been a close look like this double, and we need to write here the again x. So I try to, is it working and not working? So let's see what happened. Just output has been gotten, yeah, absolutely right. So we can easily get a exponential form also. This is a way. So the formal representations of the derivatives can then evaluate the calling the dot method and this one. So simply dot derivative is a also you can say do it methods. So d dot do it means you can express. Let's see another. If you write here d dot do it and parenthesis, so it can do it means it can just look here again differentiate. So this pattern is evaluate and the recurring throughout the symbol. So let's try again do it. Okay, so you can easily solve it again and again. So this is a basic way the differentiations. Similarly, let's try here integration. So I am going to write here integrations has been written. So integral are the evaluated using the function simply dot integrate. The formal integrals can be the represented simply dot integrals. So in this case simply dot derivatives we can explicitly evaluate the calling like dot it methods. So integrals come in two basic form: definite integrals, because we have already in the mathematics there are two. One is the definite integral, another is the indefinite integral. So where we define the integral has a specify the integration's limit and can be interpreted as an area, you can say just a volume. So integral doesn't have integrations limits and denotes the anti-derivatives also. So inverse of the derivatives of a functions is also called anti-derivatives. So simply handles the both indefinite and definite integrals, and we can use the simply dot integrate function. So just I try the single variable a on pattern, just like excuse me, a as a variable, b as a variable, c and another need to the a and b, x comma y need to write here will equal to simply dot symbol symbols and bracket start double colon a comma b comma x comma y, and need to write here as a functions. So first like here need to give here f will equal to simply dot function f x. So see here f as a functions, f double quotations and this one. So I think this has been a problem. What happens, simply f as a functions I am going to take here. So let's see s y m p y f u n c t i o n f I have written here. Okay, so let's here, yeah, functions has been created. Now I am going to write here equation simply dot integrate as a function f. Let's see here, this has been written look like a functions because yeah, f x dx, but integrate integrate has not look like this way. So what happens, simply dot, so integrations has been written, so integration symbol is not here, so need to 1 2 3 I think simply no, something is happened. I think it is possible to can has been created unexpected index line 3. No, is it right here? This is a way to write here, so I try here again. So it may be, but it is an integral part, so I try here the sum equation look like here. I am going to write here simply dot in t e g e I n t g r a t e integrate f look like this. Yeah, it has been integrated the same way, but I try one is the more f comma another parenthesis like here x comma a comma b. And why did it happen? Anything? Just I try the integrate. Yeah, right here. Yeah, means only integration symbol is not represent. I think something has, but it is work. It is working as properly. So let's see some. I think just we can write here f and x as a function. Simply integrations as a written, but it has been fine. Let's try some examples, then it will be clear. So it is working or not working. So just I am going to write here simply dot integrate here. So integrate, and now I am using simply dot sin x dot sin and x. Then it can be easily, is it working and not working properly. Yeah, right, absolutely. Sin x has been integrated and we have gotten the minus cos x. So I think it is working properly, but here we are not able to see the symbols, don't worry. So I try to solve in the next class. So I hope these are the clear, so how integrations and differentiations both can be solved through a simply. So now the definite integrals. So let's see, sometime I write here, okay, sometime I am going to write here as this way, like a simply p dot integral integrate and bracket start simply dot exp bracket start minus x to the power. So you write here double x to the power 2 and again bracket start x comma 0 and again you can use here comma twice. Look like this, and I try what is look like a, so have I gotten any output? Look like a, yeah, under root x by 2. So you can easily, so computing integral symbolics in a general difficult problem, but we can easily solve this problem and most of the time. So we can easily solve this type of the problem. I can also write here, if I write here expr will equal to new equation x plus y to the power something. So look like a parenthesis x plus y and to the power 2. Now I am going to solve simply dot integrate and expr, so expr plus x. So let's see, just try here. So I hope it is possible to print it here. Yeah, it has been printed properly, so don't have any problem. So we can easily solve integrations and differentiation problem within a seconds. Same thing, just if I created some series, because series expansions are an important tools for the many disciplines in a computing, and most of the time just if I write as a most of the functions can be written as a like a polynomials with the coefficients and something, and then we can derive these functions and integrate these functions. So I try to next time just series, and other also is the limits, then we can also sum and products of these equations also. Okay, so I hope as it this will be the good, and after that this class we will try the linear algebra, so all the matrices can write simply form. Thank you.